The next is question number 12. In this we have A and B. So we will start with A first. Observe the diagram of a below given electric circuit. This is the circuit which is given. Find the total resistance and total current of this circuit. So if you see the circuit, here we have three resistors: 12 ohm, 8 ohm, 16 ohm and 3 ohm. So these are the three resistors, and here we have a 9-volt battery. So voltage is 9 volt. We have three resistors, and the question is we have to find out total resistance for the whole circuit and total current. How to find out the total resistance of the circuit? First you have to see how these resistors are connected. Now you can see the first three resistance 12, 8 and 16, these all are connected parallel to each other. Then what you have to do? We have to find out the effective resistance for these three by using parallel connection formula. And then whatever answer, whatever effective resistance we are going to get it here, that effective resistance and this 3 ohm, now these both are connected in series. And by using series combination formula, we have to find out the effective resistance for these two. Then whatever answer we will get, that is nothing but our total resistance. Once we get the total resistance, then we can use that total resistance to find out total current by using Ohm's law. So let's start solving. First we will write down what all given values and then we will start solving. So here we will write first given. So what all values we have? We have four resistors. The resistors which are connected here in parallel, we will write it as R1, R2 and R3. So I'll write R1 12 ohm, then R2 I will write 8 ohm, then R3 I'll write 16 ohm, and these all are connected in parallel. So I'll write it here parallel. One more resistor we have, that I'll write R4, and for this I'll write 3 ohm, and these both have series combination. So I'll write it here series just for our information. Now leaving this, what we have? We have a voltage, that is capital V is equals to 9 volt. So these all values we have. First we will find out total resistance. So I'll write it here. First find total resistance. To find this total resistance, what we have to do, as I told, first we have to find out the effective resistance for these three which are in parallel, and then we have to find out for these two which are in series. So I'll write it here. The formula, that is RT, total resistance, is equals to what? RP, that is effective resistance in parallel, plus another resistance that I'll write RS, or I can write it as R4 because here I have labeled as R4. Now to find out RP, first we have to use the formula for parallel combination. So RP is equals to R1 1 divided by R2, then I have 1 divided by R3. So why I have taken R1, R2, R3? So you can see the diagram. These R1, R2, R3 are connected in parallel. So these three I have used in this formula. Now substitute all the values. So I'll write it here. So sorry, here little bit of changes we have to do. That is, it is not RP, it is 1 by RP we should write. 1 by RP is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Make these all the correction in your notes also. So now we will substitute the values. 1 by Rp is equals to 1 divided by 12 plus 1 divided by 8 plus 1 divided by 16. Now what you have to do? You have to take the LCM of these three. So find out the LCM of these three, and to find out the LCM, what I'll do? I'll find it out here itself. So I'll write 12, 8 and 16. So what prime number we can take? We can take the smallest 2 as prime number. 2 6 the 12, 2 4 the 8, 2 8 the 16. Then again 2 3 the 6, 2 2 the 4, 2 4 the 8. Now 2 1 the 2, 2 2 the 4. 3 will not come in 2 table. Therefore 3 we will keep as it is. Now I'll take again 2, 2 1s are 2, 1 as it is, 3 as it is. Now I'll take 3. So 3 1s are 3, then 1 and then 1. So now I can find out LCM. LCM is equals to, multiply these all the prime numbers, 2 into 2 into 2 into 2. So we have to take 4 times. You can see here 1, 2, 3, 4 and now 3. So 3. So multiply this. 2's are 4, 2's are 4. So 4 into 3. Now multiply this 4 into 4, 4 4's are 16. 16 into 3, 16 into 3 will be 48. So therefore, our LCM we got 48. Now substitute this LCM into our sum. So I'll write it here. 1 by RP is equals to, write down LCM 48. Now multiply this. Now you can see 12, how much is the 48? 12. 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are. Then 8 how much is 8 6 are, and 16 how much are 16 threes are. So now calculate, here it will be 4 plus 6 plus 3. So 1 by Rp is equals to, what we are going to get? 6 plus 4 is 10, 10 plus 3 will be 13. It will be 13 divided by 48. Now it is 1 by Rp. So reverse this, we will get the value of Rp. Rp is equals to, reverse this also, we will get 48 divided by 13 like this here. Now we will divide 48 by 13. So let me divide it on the side. So here I'll divide it. So I'll write 48. Here I'll write 13. So once we divide, what we are going to get? 13 threes are 39. Now see, so minus this, we will get 9. Here I'll get 0. I will take here 0. Here it will be decimal. 13 six are, what we are going to get? 78. So I'll write it 78. 2. Then here I'm going to get 1. Another 0 I'll take. 13 nines are, it will be 1. 1 7. So what I'm going to get it here? 3. Here it is 0 and then 0 and it continues. So we will stop our calculation here. So I am going to get RP values as 3.69 and the unit is ohm. Remember, always we should write it units. So it is a resistance, so I should write it ohm. So here we got RP value. Now to find out total resistance, what we have to do, you can see this formula. We have to add this another resistance. This is the effective resistance for these three. So if you tell me to draw the diagram, it will be like this. Now see here, I am redrawing the structure. So now I got effective resistance of these three. It is 3.69, and to this there is another resistance which is connected, and that is of 3 ohm, and this whole thing is connected to the battery like this. This is here switch. Now you can see how it is looking. This effective resistance and this 3 ohm both are connected in series. Now if you use the series combination formula, we can easily find out the total resistance, and therefore, so now use the formula to calculate total resistance. RT is equals to, what is the formula? This is RP plus R4, or I can take RS. So I'll write both here so that you should not get confused. So RT is equals to, what is RP? We have got just now 3.69, and what is R4 or RS? It is 3. So therefore total we are going to get 6.69 ohm. This is the answer of total resistance. So we got the total resistance in the circuit. So here our first, that is find total resistance, is finished. Now we have to find out total current in the circuit. So I'll write it here. Find total current. Total current in circuit. So here we are going to use a simple Ohm's law formula, and the formula is, that is V is equals to IR, and as we have to find out current, we will shift this R on the LHS side. So the formula will change. I is equals to V divided by R. Now substitute the values, that is I is equals to, what we have here, we have the values of V as well as R. So first we will write down the values. I question mark, V how much volt? 9 volt we have, and R just now we have calculated total resistance 6.69 ohm. So these are the values which I have to substitute here. So let me solve it on the another page because it will be little bit of lengthy because I have to show the calculations. So I'll write it once again here. So you should not get confused. Find total current in the circuit. So what is the formula? V is equals to IR. We are going to use Ohm's law. Rearrange it. I is equals to V divided by R. And the values what we have? V we have 9 volt. R we have, how much we have? 6.69 ohm. So substitute I is equals to 9 divided by 6.69. It will be difficult to divide it with this decimal. So decimal we will shift it on the two places. 1, 2. Here we are going to shift it on the RHS side. Once we shift it on the two-digit side twice, then on the numerator side we have to multiply with 100. Here we have to multiply with 100 because we are shifting this decimal on the second position on the RHS side. And then what I can get? I is equals to 9 into 100 divided by, now this you can write 669. And this will be how much? 900 divided by 669. Now this we have to divide, we will get our answer. So let me divide it here. Here I will write 900 and here 669. So first I will divide as 669. 1 are 669. So here I will get how much? 1, 3. Here I'll get 2. Then I'll take it 0 here. Then decimal. Then 669 3s are 2007. Then what I should write it here? 3. Then here it will be 0, 3, 0. Here I'll take one more 0. Then 669 4s are I'll do. Here I will get 2, 6, 7, 6. What I'm going to get here? 4, 5. Then here I'll get 3. Here I'll get 0. I will keep one more 0. Then 669 5s are 3, 3, 4, 5. And here I'm going to get 5, then 9, here 1, 0, and you can continue this again. But here we will stop and we will write our answer. I is equals to, that is current is equals to 1.345 and the current unit is what? Ampere. So this is the answer for current. So total current is 1.345 ampere and the total resistance is what we got? It is 6.69 ohm. This is the answer. So here we complete the question that is from 12. Now we will see the next question on the next page.